So, good day once again. So, our content for today is about the Gay-Lussac gas law and also the combined gas law. But first, we will discuss what is a Gay-Lussac gas law. So, as we all know, that a gas law has 5 types. We have the Boyle's law, Charles law, Gay-Lussac gas law, combined gas law, and last one is the ideal gas law. So during the last video, we've discussed already the Boyle's law and the Charles law, and also we already given different problems to solve or how to solve the Charles and the Boyle's law. So today we will discuss Gay-Lussac gas law. So as you all know, that in our previous session, we already identify what Gay-Lussac gas law is. So this one, we will use this one as our formula. So a Gay-Lussac gas law is a special case of ideal gas where volume of the gas is held constant, which means that our volume is already constant. So when volume is held constant, so the pressure exerted by a gas is directly proportional to the absolute temperature of the gas, which means that if the volume daw is already or it is in constant measurement, the pressure of or by a gas is directly proportional to the temperature. So which means that a Gay-Lussac law is a relationship between the pressure and the temperature. So we will give example of Gay-Lussac law. So for our number 1 example, a 20-liter cylinder combines at 6 atm of a gas at 27 degrees Celsius. What would be the pressure if the gas heated was to 77 degrees Celsius, which means that our 6 atm is our initial pressure and our 27 degrees Celsius is our initial temperature and 77 degrees Celsius is our final temperature. So as what we have discussed in our last content, that when we are using the gas law, we will always use Kelvin as our temperature. So after that, we will write our given. So P1 is equivalent to 6 atm, which is our initial pressure. Then T1 or our initial temperature is 27 plus 273 Kelvin. So we're just going to add the two value. So 27 plus 273 is equivalent to 300. So this is now our temperature for our initial. Then we have our P2, which is the unknown. So this is the unknown, the final pressure, because according to our question, what would be the pressure? So this is the question. So for our temperature 2, we have 77 plus 273 Kelvin. So you're just going to add the two value. So 77 plus 273 is equivalent to 350 Kelvin. So naana tay initial temperature and final temperature. So now we can now solve for the final pressure. So for our solution, so P1 is equivalent to T1 equals P2 over T2. So since pressure ato ang ginapangita, so pressure is equivalent to P initial multiply to T final divided to initial temperature. So which means that there is ang ato ang pressure to ang nabilin. So we can now write the value. So 6 atm multiply to 350 Kelvin divided to 300 Kelvin. So we can now cancel out our temperature unit, then ang mabili nato is the atmospheric pressure. So P2 is equivalent to, so all you have to do is to 6 times 350 then divide it to 300. So our pressure is 7 atm. So as you can see, as the pressure increases, also the temperature increases. So diba, our initial temperature is only 300 Kelvin, and then our final temperature is only 350 Kelvin. So which means that if the temperature increases, also the pressure increases. So that is a Gay-Lussac law. So for another example, so for our number 2 example, if a gas is cold from 323 Kelvin to 273.15 Kelvin and volume is kept constant, so which means that our volume is still constant, what final pressure would result if the original pressure was 750 mmHg? So the last time we discussed about the pressure, that a 1 mmHg is equivalent also to 1 TORR, or also for ATM. So our problem here is to solve for the final pressure, just like what we've done now for example number 1. So as you can see in our temperature, that it is already in Kelvin unit. So there's no need for us to calculate or to convert it from Celsius to temperature, kay diretso naman siya naka-Kelvin in terms of its unit. So all we have to do na lang is to transpose the value, and then we can now get our, or we can now solve for our final pressure. So first, we will write for our given. So our initial pressure is 750 mmHg. Our T1 is 323 Kelvin. Our T2 is 273.15. And our pressure 2 is the unknown. So yun yung ating i-solve. So the same formula magigamit na to paganina sa atong first example will be used sa atong example number 2. So P2 is equivalent to P1 multiply to T2 divided to T1. So write the value of each. So P1 750 mmHg, or millimeter of mercury, multiply to 273.15 Kelvin divided to 3 to 3. Cancel out the unit, then we can now get our pressure 2. So 750 multiplied to 273.15 divided to 323 is equivalent to, yes, it is correct, 634.25 mm. That's G. So there's no need for us to convert our unit because mmSG also represent the unit for pressure. And for the fourth law of gas law is we have the combined gas law wherein, or which means that this law combines the three laws of gas. So we have the Boyle's law, the Charles law, and the Gay-Lussac law. So as you all know that these different laws, relationship different. So nasa kanya-kanyang relationship, but these four types of law combine those relationship into one. So where pressure, volume, and temperature meets. So this combines law states that the ratio of the product of pressure and volume and absolute temperature of a gas is equal to constant. So in this fourth type of gas law, we also need an initial and also the final value of each. So the pressure, the volume, and the temperature. So this is the fourth gas law. And for the examples, so for our number one example for combined gas law, a gas has a volume of 800 ml, which is our initial volume, at negative 23 degrees Celsius, which is our initial temperature. So, and a 300 torr, what volume of the gas B at 277 degrees Celsius and 600 torr of pressure. So as you can observe that as the temperature decreases, also the pressure decreases. Pero pag if the temperature increases, also the rest increases. So diba, the volume is 800 and our atmospheric pressure is 300. So which means that ang ato ang results sa ato ang volume is also increases as you observe for our initial volume, initial temperature, and initial pressure. So for that, we will write first the given. 1 is 300. Volume 1. So remember, since this is a degree Celsius, we need to convert it into Kelvin. So 23 plus negative 23 plus 273 is equivalent to 250 Kelvin. So we have now for our initials. So let's go for our final. So what we are looking for is the volume. So our final volume is unknown. Our pressure is 600 and our final temperature is 277 plus, so 277 plus 273, so yes, it is. So that is our final temperature. So we can now solve for our volume final, which is unknown, or which is the unknown. So volume, so have P1, V1, and here P2 and P1. So this is the formula that we are going to use since volume 2 is the unknown. Diba? Atong formula talaga is this one. P1 V1 over T1 equals to P2 volume 2 over. Ayan. So since volume 2 man is the unknown, so si P2 nagbaba, then si temperature final is na sa taas. So we can now solve for our volume. So write the given 300 TORR multiply to 800 ml multiply to 550 Kelvin divided to 600 TORR. Then we have our initial temperature, which is 250 Kelvin. So next, we need to cancel like units. So ang mabili na lang nato is the ml. So volume 2, so 300 multiplied to 800 multiplied to 550. So the results, and then 600 multiplied to 250 right here, and then we divide. So the result is 880 ml. So this is now our final volume. So as you observe that as the temperature increases and the atmospheric pressure increases, also the volume increases. So that is for example number 1. So for our second example, for a combined gas law, so a sample of gas has a volume of 2 liter and a pressure of 0.750 kilopascal when its temperature is only 25 degrees Celsius. So which means that in a temperature of 25 degrees Celsius, our volume is only 2 liters with a pressure of 0.750 kilopascal. So if the volume is expanded to 4 liters, which means that there is an increase of volume, and the pressure is reduced, which means that there is a decreasing of pressure to 0.500 kPa. What must be the temperature become? So which means that we are going to solve for the final temperature. So alam naman natin that if the temperature, sa temperature we always use Kelvin. So first we're going to write the given. So P1, which is equivalent to 0.750 kPa, and our pressure 1 is, and our volume, initial volume is 2 liter, and our temperature is equivalent to 25 plus 273 Kelvin. So 25 plus 273 is equivalent to 298 Kelvin. So we have now our initial temperature. Then for our second, so our unknown here is the final temperature. So our pressure reduced to 0.500 kPa, and our volume is 4 liter. So we can now solve, or pwede na nato isolve ang ato ang problem, since we determine naman that the temperature is not available, or siya ang ato ang ginapangita. So for our computation, so temperature is equals to P2V2T1 over P1 and V1. So this is the formula that we are going to use. So we can now write, so 0.500 kPa multiply to our volume, which is 4 liter, multiply to our temperature, which is 298 Kelvin, divided to 0.750 kPa multiply to our volume initial, which is 2 liter. So 0.500, before that we need to cancel like unit. Billion is the Kelvin. So 0.500 multiply to 4 liter multiply to 298 is equivalent to 596. So 0.750 multiply to 2 liter is equivalent to 1.5. So 596 divided to 1.5 is equivalent to 397 Kelvin. So this is now our final temperature for a sample of gas. So that's it. Thank you for your time. Good day and God bless.